Okay, let's kick things off then. Welcome to the SingularityCE community call for July. Today, so this month, we are lucky to have a demonstration from Vanessa, who's been kind enough to join us and prepare something, showing off the Singularity HPC project, so SHPC, which is related to kind of combining the power of containers and module files, which are commonly used in HPC systems. So we'll kick off with that in a second, and then we'll have the usual updates on development and a section for any other business and questions at the end as usual. So without any further ado, I'll hand it over to Vanessa. Thanks for joining, Vanessa. We look forward to hearing all about the project.
Alrighty, let's get started. I'm going to share my screen. Hope I choose the right desktop. Can you all see my little terminal here? Yes? Yep. I don't see the Zoom. Okay, and fantastic. So that is correct. First of all, welcome everyone. Welcome all y'all container friends. I am Vanessa, or VSOC or V, or whatever you'd really like to call me. And today I'm here to talk to you about Singularity HPC. And Dave already kind of gave away the hints of what it is. So I want to start with kind of talking, also maybe repeating some of what Dave said, but I want to answer a question off the bat, like, so Singularity SHPC means Singularity Registry HPC. And I want to start with a question like, why do I have such a terrible name? So to kind of step back to when we first made it, the idea was like, okay, if we had a container registry, what would it look like on HPC? Because we're used to registries with RESTful APIs, you know, the distribution spec or Docker Hub. But on HPC, you have like a kind of a different beast here. And so what came to mind very naturally, as y'all can see right here, sort of the bread and butter of HPC, or at least something that's been on all the systems that I've encountered, is some kind of environment modules, so LMOD or environment modules. So this early idea was like, maybe we can kind of expose containers as modules. And so then either an administrator or a user could actually like install containers, quote, install containers, have them, their aliases exposed as modules, and use them just as they would modules. So that is sort of the rationale of SHPC. Let's get started. So here is my terminal. I am running on a lovely VM. It has Singularity. Let's see, let's check out the version. 3.10 Jammy. That's a pretty cool name. We also have LMOD on here. I have Git, and this is super cool. This is a cloud node, but we have a Slurm cluster, so I have like SQ and all that good stuff. So if you're a user, or I guess if you're an admin too, the first thing that you're probably going to do is clone the repository. So SHPC is slightly different than your standard Python module because you actually are better off either cloning the repository like this, or getting a release. And the reason is because if we go in here, we peek inside, there's actually this registry folder that has all of the modules that, technically could be installed along a Python installation, but this is something you're going to be editing or changing or otherwise wanting to look at. So generally, it's kind of nice to just clone it and then have it right here. And then of course, here's SHP the software. Okay, so we just cloned it. Probably next, we want to create a virtual environment. I don't know how y'all like to create your virtual environments. I like to do this. Can you see the text okay? Is that big enough?
It is here. If it's too small for anyone, please raise your hand.
Yeah, if it's too small, if something's going wrong that I'm not aware of, it's morning for me. It's pretty early over here for a dinosaur. And I'm walking on a treadmill, so if I miss something, just let me know and I will do that. So we just sourced our environment. We're now going to install SHPC. E means that it's a development install, which we don't technically have to do, but I like to do for development. And then we're going to choose all. This is going to do the magic and install it. Alrighty. So once you do that, you are going to have an executable SHPC on your path. And we're going to look a little bit more at that. But probably the first thing you want to do is install a module, right? I mean, that's the first thing I'd want to do. So you can either kind of manually look in that registry folder, or you can come here this is sort of our official kind of registry for searchable things. So let's say that, so my role at the lab, we're doing a lot of binary analysis and solver stuff, meaning we need ASP or answer set programming. So I'm going to search for a little library called Klingo. Sorry to disappoint, not Klingon, Klingo. Klingo is an ASP system to ground and solve problems. And I say, here is the container. The address ghcr.io is GitHub Container Registry. So this is the module that I want to install with SHPC. I could click here and I could get really specific commands about how to install it, how to load it, how to run different commands that it provides. But that's actually the stuff we're going to walk through. So I'll just show y'all. So let's do SHPC install. So what you're going to see happen extremely quickly, because this node is just crazy fast, and also it's cached. There's that too. So because SHPC by default is configured to use Singularity, it's going to pull the container, put it here in this, this file named by its hash. Here's the container URI. Again, we're pulling by the hash, and it says, okay, this module was be created. But wait a minute, I didn't really show you how this is set up. So there's this one settings file, settings.yaml or YML. And if we take a look, this is going to be where there's sort of all the important stuff that you may or may not want to tweak before you kind of install stuff. So right now we support 2 module systems, LMOD and the other environment modules, which the alias is TCL. You can tweak your editor. I made the default Vim. Some people are probably going to bite my head off and be like, why is it not Vmax? It's Vim. You can change it. The container technology here is Singularity. I think it's unlikely you'd put Docker here. Maybe you would, but you could also there's also support for Podman if you want to use Podman too. Registry is a list of places that we're going to be looking for these container YAML recipes, which I'll show you in a little bit. The default is, as we saw, in the root directory under registry. In terms of where stuff gets installed, well, you get to control that too. So right now, the module files are going to be installed again to the root directory under modules. I didn't change that. This is sort of a detail that you don't really need to edit that has to do with the model name. Same with versions. There's different ways that you can control the version that is sort of installed, sort of laid out here. We're going to leave the default and let the module system decide. You can also choose where your containers go. So probably many of you have either an organized, structure or way that you're organizing your modules and containers, or it could just be you clone this to your home node, which fills up really quickly, and you need to put this somewhere to where there's more space. We have this abstraction called views. A view is conceptually like a database view, where it's sort of a slice, quotes, symlinks of a particular set of modules that you have. We'll go over that in a little more. And then down here are more customizations. So for example, we have this thing called wrapper scripts that when you enable it, instead of creating sort of an alias for a particular container command, it actually creates a script that has that in it. And the reason you want to do this, the reason that we tested this for, is because it works much better with workflow manager tools. So we tested this with Nextflow, and it worked great. You can also control container features. We'll talk about that a little bit later. Alrighty, so I didn't touch this because the defaults are set intentionally to be kind of reasonable for the users, but you can imagine coming in here and having lots of preferences around things as people usually do. Okay, so now that we've installed something, we can do SHPC show to see all of the modules available, but once we've installed something, we can do SHPC list. And there's our little module. So we installed Klingo, we installed 5.5.1. So the way I would interact with Klingo now, well, let me actually show you, forgot to show you. So we have modules here. Here's our newly installed Klingo module. It's under the same namespace as the container URI, the unique resource identifier, and that's done intentionally to kind of keep things unique, because you can't have a registry with the same image twice. And so under containers, same thing, same sort of hierarchy. So we're going to do module use modules. For those of you that are familiar with modules, this will be a very recognizable command. We can then do module avail, and up here we see it. Up here we have Klingo available. So let's see. Before I show you, well, yeah, let me quickly show you kind of like the man behind the curtain. So if we look in Automus, Klingo, in this folder, there's this container.yaml. So like how the heck does SHPC know the hash to install and how does it know what aliases we're going to interact with? Well, that is the magic of this container.yaml.file. And yes, right now we have about 299 of these. So this has a Docker URI. There's other formats that can of containers you can get from different places, but Docker is like the most widely used. You can put a URL. This is mostly for that documentation page. So someone could click on it and be like, more information about Klingo. It has a maintainer, description, and the most important part is really these two sections here. So here we have a listing of tags, so the name of the tags and the digest. And then this is what the container.yaml is considering latest. And then down here we have key value pairs for aliases, and I'll show you a little bit later how this gets rendered into the module. Alrighty, so we've loaded Klingo. Let's or no, I don't think we did load Klingo. Did we load Klingo? I don't think we loaded Klingo. So we load it, and then we can do module help, same thing. And so this is going to quickly show you in this module help where the container is. And the cool thing about SHPC is if I had left that aliases list totally empty, not defined anything, it is automatically going to generate me all of these commands to interact with the container. So Klingo run, that would be equivalent to running this really long command, except we add extra stuff, like we have that environment file that's automatically generated that you could either get environment variables from the recipe or just manually update to always have a special environment for your container. There's a shell, there's an exec, and there's even sort of courtesy functions for inspecting different metadata in the container. Heck, you can even run Klingo container and have a command that gives you that path to the container. So that is the module help. So let's, without further ado, shall we run Klingo? Yes? Okay, so let's run Klingo, and it's gonna open an interactive prompt that we read from stdn. Okay, so let's say there is a dinosaur named Vanessa. So that's how you write an atom or a fact in Klingo. You do like a little parentheses thing with a thing and then a period. We're gonna say there's a rule. So now a rule, someone is a dinosaur. This person has a name. If you have a rule that they're a dinosaur with that name. Okay, now we're going to press Control D, and Klingo says, we have an answer. Vanessa is a dinosaur, and that's a very quick preview of just Klingo. But the cool thing is, this command was actually that command up here. This is interacting with a container, but you would never know because it's just managed by the module. And we didn't install with wrapper scripts, but if we did install with wrapper scripts, we would still have this Klingo, which would be in a bin folder added to our path, and it would produce the same result. Okay, so this can also work with Slurm. So thankfully we have a really cool little Slurm cluster on here. So I have prepared in advance this little job. So the job is going to do what you'd expect most Slurm jobs to do that are using modules. We're going to run this use command again, targeting our home. We're going to load the module, and then we're going to run this dinosaur.lp, which is the logic program, and that's right here. It's like literally the same thing. So let's do sbatch job.shell. And it's going to finish so fast, we're not going to see it running. I've tried when I was practicing, it's too fast. But here's the output. It's like exactly the same. So that basically is taking our command or taking our container module, loading it, running it on Slurm. Before I continue, does anyone have any quick questions?
Quick question.
Yep, go ahead.
I think I missed the actual commands. Are they aliases or scripts?
Oh, yeah.
And if they were scripts, who were they? I just noticed in like Bash scripting, for instance, some cases aliases just don't get the same behavior as first class script citizens.
So let's look directly at the module file. Go back into SHPC. So to answer your question, it could be either. We have wrapper scripts off, so right now these are indeed aliases. So if we look deeper and we look into this module file, module.lua, and there's the environment file that I also mentioned. So up here is the help that we saw earlier. That's sort of just a human courtesy thing. So let's now walk through this module file a little bit and talk about how it's working. So we haven't talked about views yet. but there is the support that is going to allow us to load a specific set of views. I think I'll wait to talk about that. That's these lines up to here. So we basically define a module directory. This is a setting, the Singularity shell. This was also a setting in the settings.yaml. These are other environment variables that if they are set, we use them. If they're not, then we set them to sort of be empty. Down here, here's our container path, long thing here. That's set as Singularity container. So here in, this is Lua, so this isn't TCL, but here's how you set a shell function. This is saying, okay, make this alias Klingo container, make it just echo the container path. And the reason that there's two sections here is because they're for, I believe they're for two different shells. I think the first one is more a bash type shell, and this one is CSH, C shell. Here's here's defining the aliases for a shell, exec, run, and inspect. And then we basically use the set shell function to do that. Now, one thing that you're probably familiar with modules is that, let's say you have Python loaded, and then you load a different version of Python. The module system is smart enough to be like, oh, there's a conflict. I'm unloading this other one because you didn't do that. So we do that too. We create a conflict for basically any aliases with the same name. So if I had installed another version of Klingo and I tried to load it, it would unload this first one because they both have Klingo. So this wasn't rendered. Here is basically, it would do the same thing. It actually would skip the set shell function. And what SHTP would have done, it would have generated a bin in that module folder with actual files, so actual scripts that basically run these same commands, except then we would just add them to the path. So the module file would just add them to the path. So we'd find this Klingo quote executable, not a compiled executable or anything on our path. But instead, because we're just using aliases, what we ultimately do for them is we just set it here as the shell function. And there's little tweaks that you need to do if it's just bash. Here's some metadata, and here's all those specific kind of commands that appear with any container. So this syntax kind of varies based on the module system too. So basically, if I installed for TCL, which I don't have on the system, it would look similar, a little bit different. Does that answer your question a little bit?
Yeah, it did. Yeah, thanks. I mean, it's an elegant way to handle it. I forget the specific use cases, but I had just seen whenever you get a complicated stack with modules, sometimes, unless, for instance, you stick with bash, calling bash or something, the aliases seem to get lost sometimes. Like a Python binary wouldn't know of the alias from a previous process. But yeah, that answers the question, and it's a nice way to do it. Thanks.
Yeah, and that is exactly why we have these wrapper scripts, because we were also finding that if I wanted to, load a module and use it with Nextflow, it just didn't work very well. So with an actual wrapper script, you actually just have a script that's added to your path, so it's not gonna, sort of get lost as some of these aliases seem to do. Okay, so we looked a little bit behind the curtain. We looked at the container.yaml. We just looked at the module file. We looked at module help. Let's see. I want to, probably it's useful now to talk about views. So imagine that you install SHPC and you manage a bunch of users on a cluster, and I guess it could just be yourself, but the case that happens that people run into is the fact that they may have a certain set of modules and they really need to load it with one particular version of MPI. Or maybe you have a set of modules that work with GPU and you want to keep them separate. So SHPC has this concept of views, and a view, as I said earlier, is like a database view in that it's going to take that central install of modules that you have and basically create some symlinks to the module files. So you will only load a subset with a little bit of tweaks that I'll show you, but it gives you kind of more control of that space. So let's say, again, we're gonna pretend in my use case, I have Klingo. I wanna create a view called solver. All my favorite solver modules, I suppose. Okay, so we just created the view. What that means is that it's going to be in this views folder. Right now, that's just this view.yaml. We haven't actually added any modules to it yet. So now we're going to see if we did view list solver, this would list the modules in the view. And guess what? There aren't any. Major disappointment. If we do SHPC view edit solver, this gives us a glimpse into that little modules thing, and we can indeed say, okay, the name is solver. It has no modules. And here's kind of the main thing I was talking about, that there could be some special set of system modules that I always want to load when I'm using this particular view. So let's see. Now let's add Klingo to our view. So we're going to do SHPC view install to solver. GitHub container registry.io, Autonomous, Klingo. Yay, so now if we do SHPC view list solver, we see that Klingo is installed. So to kind of show you the little bit of different interaction, I forget how to unload modules. Let's try module upload. Not that one. Let's do module unload and module purge, I think it is. Did that work? Yes, that worked. Okay, so now we're gonna module load. And so the cool thing about views is that, oh, I forgot to add it to our, I forgot a step, folks. So one thing I forgot to show you is that SHPC view get and then the name gives you the path to the view. And obviously, like if you haven't run that, then our module system can't know about it. So we can use module use and then that little thing. Now we should be able to do module load Klingo 5.5.1. So that's another benefit of modules, is that since it's assumed that you're installing to like a smaller namespace, we actually simplify the naming convention a lot. So you don't have to do like ghcr.io, Autonomous, you know, those names get really long and annoying. And personally, it was bothering me. So now we can again module list. Now Klingo is loaded and it's the same module, but it's just nice and shorter. And if we look at our views folder, we see now that we have this symbolic link from this file that we just loaded to the original one. And the original one is still pointing at the same container, so you're not getting redundancies with respect to containers. So we could again do Klingo and let's run it on dinosaur.lp, and yay, it still works. So that's great. If we did want to add system modules, I didn't add any system modules here, so I don't have any, but we would do SHPC view add to solver, and then you'd list them. So you'd be like open MPI and cool solver thing. So, and then the way it works then when you install that, those modules will get added to be loaded in, not in the module.yaml, but in a version file that is hidden in here. So let's see. Now, okay, so let's talk about adding, actually I should stop. Are there any questions up to this point about views? Alrighty.
I have some general questions, but nothing on views. So
okay.
I'll wait.
Yeah, no, I can take those at the end or whatever. So right now we have I think we have 299 registry modules. And a lot of those, unfortunately, I added manually because there just like was no other way to do it. So let's talk about what it means. So let's say that you start using SHPC and you're like, oh, there's like a missing container. I really want it there. Well, the basic thing that you can do is you can open a pull request. So I don't remember, was this someone that someone added? Well, you can open a pull request to basically add this container.yaml. Let's see if we have any old ones to look at. Author, let's look for Marco. That's weird, he's not here. De la Pierre. Huh, I got that right. Yeah, so for example, here's a bunch of containers that were added from Posy, just like tweaking them. So basically the process for submitting a container is literally just doing a pull request and adding the registry file. And thankfully, because I personally got tired of manually going to like Docker Hub pages and copy pasting the aliases, there's actually a command called add that's going to help you to generate most of the metadata that you need for a container. So let's walk through that quickly right now. So Docker Hub, Vanessa, let's go to my favorite Pokemon, extremely important HPC software is generating ASCII NEMA of Pokemon. So here's our container that we want to add. So let's go back here. So the way we're going to do it is we're going to do SHPC add, It's a Docker alias, Vanessa Pokemon. Okay. Yay, so this will generate this container.yaml here. At this point, you'd be like, you know, I want to kind of just check this metadata. Let me take a look. Open it up. And so most of this import is generated for you. You might want to change this to the Docker Hub side, or if you have a documentation site. Other than that, put your maintainer alias on GitHub here, or your name. This is where we haven't talked a lot about features yet. I will talk about them. So basically, to summarize here, there's in the settings.yaml, that's sort of the admin control of features. That's where you could say, my cluster has NVIDIA GPUs, or my cluster doesn't have any GPUs. And then in a container file, if we uncommented this, this would say, okay, when I'm installing the container, if the cluster supports some GPU, make customizations to the module to allow for that. So if you're familiar with Singularity, you know, at least, I don't know if this is still the same, but early Singularity, you could add the --NV flag for NVIDIA. So that's just an example. So here's where we'll put aliases. So I happen to know there is a Pokemon command, and this was an old Python library, so it's going to be in opt conda bin Pokemon. And some might argue that this is like the most important piece of information, the fact that we're taking these containers that are kind of black boxes, and the developer is really spending the time to write down the names, not just the names of the aliases, but where they are to make it easy for you people to use. So here's where we might do a custom environment variable. I don't know if you have preferences for specific environment variable in a container. And thankfully, SHPC now does the work for us to get this latest tag. So we don't have to. And then here's the Docker URI. Okay, so does this look good? This looks good. Let's go with this and see what happens. So we'll do SHPC install Vanessa Pokemon. There's the pull. Again, it's using cache. Awesome, was installed. So now let's see if it works. So module use modules, module load Vanessa Pokemon. So if that worked, we should have a Pokemon command. Nice. Now we get to do some important HPC work, catching Pokemon. Here we have Darumaka, Ferrothorn, Spinda, he's kind of cute. Choodle. Okay, I'm done. So the other thing I want to kind of show you is one of these special automatically generated alias commands. So here we're in the Singularity container, and if you remember, we exported an envar, and there it is. And again, that's done. If you're familiar with Singularity, there's this little Singularity D folder, because I don't have good auto completion. And then, wonder why that's not working great. I'll look into that a little bit later. Singularity D, it should be an environment. LS, Singularity D environment. Yeah, so here it is, 99 SHPC, this fantastic strategy of making numbered environment files that we just pray someone doesn't like make a later number them. Okay, so that is the shell command. So now, let's quickly install Golang for the next thing I want to show you. So while that's doing that, let's talk a little bit about features, because features are kind of cool. Jumping back to the browser. Alrighty, so I mentioned before that in the settings YAML, there's this container features settings. And this is where you might say, yeah, my cluster has NVIDIA GPUs. And then in the container.yaml, you'd say, yeah, this container has support for GPU. So here's the current listing of what we support. Let me make this bigger. GPU, this means that, if the container technology supports it, add the flags, default is null. We have support for NVIDIA, AMD, and none. We have support for X11 if you want to have a specific bind mount of X authority or a custom path. And same with home. It could be that for all of your containers, you want a custom home to be mounted. So these are the features we have. Of course, if there's other features that you think would be interesting to have, please open an issue and let's discuss it, that they are fairly easy to add. So that's features. So now we're going to go through the process of, let's pretend now we're system administrators and we want to, update our containers. So as a reminder, SHPC lists, I just installed Golang, And I did that because I know there's a new release and we haven't updated the module yet. So if we just installed it and we do shpc check Golang, what that's going to do is that's going to do a check between our container.yaml versions and what we had installed. So because we just installed it, it's kind of already up to date. So what we'd actually do is we do shpc update Golang. And this is actually going to ping the Docker API of a registry, look for updated digests, look for updated tags. And there we have it. So this is going to say, oh, well, looks like there's a new latest. And this is actually weird. So this, when I was testing, was 1.19, which now I see down here. But now there's this Windows Server one. So one thing as a maintainer that I'll actually do now is I'll add a filter to make sure that anything with Windows in it is not included. So every container.yaml has this custom ability to kind of add a list of filters. This is not what I want, so I would change that. But anyway, now if I do shpc check Golang, it says, no, you don't have what we deem to be latest. Of course, that is not what I would deem to be latest because that's sort of an incorrect tag. Now, you don't have to run this manually. So we have shpc bots that run actually monthly. They do this update containers thing that basically runs this, this particular update command for all the containers. And I explicitly left open this PR from beginning of the month just so I could show you, but we can see here that here's all the updates to the containers. And actually, if we find Golang, I'm going to show you what this looked like just a couple days ago. This is sort of the correct update. And so you see this filter field here. This is where, as a maintainer, I carefully check these every month. I'm going to add another filter here that's like, don't give me the Windows tag. No, nobody wants Windows here. So let's see. I want to also quickly give a shout out to my contributors. So I also left another pull request here, but so major shout out to Marco De La Pierre at the Pawsey Computers Supercomputer Center, and I think his name is pronounced Matthew Mufato. He's at the Wellcome Sanger Institute. This seriously is like one of the reasons open source gives me joy in life. If you look at various pull requests and issue boards, we have just like oodles of discussion, and it's fun and it's awesome. And if anyone is interested in SHPC, they are welcome to join our little kind of open source fun party. So something sort of in the queue and things that I can get y'all's feedback on. Views are obviously sort of limited now. It's like, okay, add modules and then add system modules. We can really customize them in any way that SHPC is already customized, so we can add details about features, some other customization I haven't thought of yet. So if you have ideas, please head over to the issue board, open an issue, let us know. Again, if you have other features that you want to add, also let us know. We have kind of looked at different support for other container technologies, although they're not added yet. Where's that little list? Let's go here. No, is it this one? Yeah. So these are the ones that are supported. I've looked into Shifter and Saurus. They don't, at least the last time I checked, Saurus wasn't able to get an exact digest that I wanted, so I wasn't content with it. But if y'all are using these container technologies and you want me to take a look again, I'd be happy to. So I think that's all I have. There's one more issue I want to kind of point out that I'm kind of interested in at the moment. So one thing that's kind of interesting that I think is a strength of SHTP, but it reflects on a larger problem that we have with containers, is this idea of exposing what's inside. And this maybe isn't even for containers. You could use this for like a Python module that you just have like installed on your system without a container. But I'm kind of thinking around this idea of, is it possible maybe to have some kind of extraction that saves a simple metadata file, kind of akin to that container.yaml, but like focused on the aliases, metadata, environment features. And then that could be maybe exposed via a static registry, an actual registry, something else. This is a little bit like the scientific file system idea I came up with in 2018, which is implemented natively in Singularity, that kind of exposes different entry points. They each have their own environment and labels. But I think there's a cool idea in here. I'm not super sure. So now that is all I have for the demo. Thank you all for attending today. I'm super glad that I was invited, and it was fun. So I guess I'll open it up for general questions.
Thanks very much, Vanessa. That was a great demo. Does anyone else have any questions before I start asking things? Okay, I'll kick it off with one then. So others might be kind of familiar with things like SPAC and EasyBuild, which put out module trees, and they can also be used to build containers. I wonder if you could just kind of give a little rundown of what's different here for the benefit of people who are wondering how it differs from module and container support there.
Oh, sure. So I'm more familiar with SPAC, but I think EasyBuild is similar, but I'll talk to SPAC first. So SPAC has a command called containerize. So if you run SPAC containerize on usually a spac.yaml, which describes an environment, it's going to basically generate for you a Docker file that writes that same spac.yaml, creates a view, and then installs it. So right off the bat, you still would need a method to build that container in advance, push it somewhere, and then pull it down. SHPC, along with actually one other container modules thing that I found, SHPC is not concerned with building containers. It's just concerned with using them, getting the tags, getting the digests. SPAC and this other one that I found, which I don't remember, it was like the container, something collective, but it used containers and modules. It was focused around providing recipes for an admin to build into a module. And we kind of assume that you can't build on an HPC system, so we don't do that. So with SPAC, you'd have to build it. And, SPAC is, I don't want to speak poorly about SPAC. SPAC is great for research. SPAC solves a lot of problems in HPC with really hard architectures and stuff. For me, I just prefer building kind of very simple vanilla containers that have exactly what I need. So I am more likely to use the Golang base container provided on Docker Hub than try to build my own Golang container, which through experience with SPAC, what usually happens is that something will build once and then there's an update to SPAC and the whole thing breaks. So you can use SPAC to generate these container you use SPAC to generate a Docker file. You could build that and push it. And actually, I should be fair. So a lot of these containers you see are from Automous. What is Automous? So this is a project that was headed by an intern at the lab a couple summers ago, and actually we started it before he even had an interest of being an intern. But it actually builds containers from SPAC, and it pushes them to you'll recognize this template. Who made this template? So it pushes them to Docker Hub, but it also pushes the same to Singularity Registry. So any container that you see here that has Automous, to be fair, this is the Abyss that was built with SPAC. So we actually do have that builder. It's under the Automous organization on GitHub that does the work to generate the container file, to push it and provide it. In practice, it's very hard to maintain because things break a lot, but it still does make a pretty good portion of our containers. So I don't have enough experience with EasyBuild to comment on it in the same way as SPAC. I do think that it's focused on modules, and I suspect that if you use a container, it might build a container for you. Does anyone have experience here that they could speak to that?
Yeah, it's kind of similar in scope in those areas than SPAC. Yeah.
Mm-hmm. Yeah, that makes sense.
Okay.
So they're they're similar in that they both do something with containers and modules, but in my mind, they kind of solve different problems.
Okay. Does anyone else have a quick question? We'll got time for one more quick question, and then we'll move on to the development updates so we can.
Woo!
I just wanted to add one more thought on the Alias and that issue 558, if I could.
Oh, sure.
Yeah, I love that you finished with that. You were kind of reading my mind in terms of capturing the overall exposure of an interface for users to coordinate with a container. And I liked what you said about, you could interrogate the CIF information potentially. But with module, for instance, module has a way to describe the module with a help tag and the info. And you start to kind of see Singularity's help, modules help, and then the basic command system all manifesting in not really contradiction, but it can create a bit of a tricky orchestration for the user. Yeah, go ahead.
So for SHPC, the user arguably doesn't need to know about the containers. I mean, that has its pros and cons, right? The pros are that, if I want to use Klingo, I just load Klingo and I use it. I don't think about a container command, and I probably don't even look at that module help. I probably just load it and assume there's Klingo on my path. Of course, the con with any kind of abstraction like this is that then, if when something does go wrong and you do need to debug it and look into it, that's when you'd look at the module help and you'd be like, oh, this is a Singularity command and there's a container, let me test that. So there is sort of one level up of understanding about containers and running containers that would be needed to do that level of debugging. But I don't think the intention, so at least with SHPC, the intention isn't to require people to know about how to do containers and all the details. Probably you need to know how to use modules, but that's like bread and butter of HPC. So most people are sort of forced into it. With respect to this registry idea, I think the higher level idea is like, every piece of software, whether it's in a container or not, like has some metadata that can be exposed. And I believe at least that there are automated ways to do that. So if you make a Python library and you have a client, you probably are using argparse. And I bet you we could figure out a way to actually, parse argparse, and maybe the same for different languages. So I guess I see your point, but I don't think that making sort of a registry of commands or making sure that you have really good help for your tool somehow makes the space of help worse or more confusing. I think it's a much more dire result if you have a tool and you don't provide the user with any documentation, and then their only resort is to try to look for man pages.
Yeah, very cool. Thank you. Thanks.
Okay, thanks very much again, Vanessa.
Yeah,
really
thanks everyone.
Interesting
That was fun.
stuff. So I'm going to move on and we'll go to a quick kind of overview of what's going on with development of Singularity at present. So the last release was the 3.10.0, and we talked about this in the last call, and we haven't had any further releases out here. It's been relatively quiet in terms of issue reports and things. So there's no 3.10.1 to talk about yet. What we do have are things starting to come into the main branch, which will land in Singularity 3.11. So some new features, and several of these actually come from Vanessa, working away on some issues. So you can now specify a hashbang to support a specific shell or interpreter in the test section of a recipe file. There's an instance stats command which will show resource usage of a specific instance if it's running in a C group, and we're going to be working to expand that so instances by default run inside a C group if they can, including instances which will run as a user, so you can always then query the resource usage. There's an addition so that overlays can be created as sparse files, so that if you're on a system where it's beneficial not to use a kind of entire space of a large overlay at once, but wait for it to fill up and grow over time, that allows you to do so. Vanessa has also added support for the Docker host environment variable if you're trying to bring containers out of the Docker daemon on your local system. And the Docker username and Docker password variables are now supported without the Singularity prefix on them. So that means that lots of the guides out there which tell you how to use other OCI and Docker tools to interact with registries that need authentication will now work much more obviously with Singularity, with those non-prefixed environment variables, which are kind of used throughout the ecosystem. If you're trying to kind of limit what's in your container at runtime, and you have maybe a system on which an administrator has set up a lot of binds by default, maybe a proj dir, data dir, or whatever, lots of file system binds. You can now say no mount bind paths to disable mounting of all of those in one go. Previously, in 3.10, you can turn off mounts one by one, but that allows you to do all of those kind of admin specified ones at the same time. And then we've got some kind of things more related to debugging and bug fixes. The key thing really is that up at the top here, if you're interested in developing on Singularity, we have an end-to-end test suite, and it's a little bit kind of cumbersome to use because of the nature of being a container runtime, which has to kind of spawn different processes and go into namespaces and things. The end-to-end test suite is quite complicated and relatively unusual. And it was a real pain to run specific tests. So we've done a bit of work that now allows you to run a specific group of tests. So only the tests, for example, which are in the version and help groups, or else you can run a test of a specific name. So the example in the changelog shows that I could ask to only run the end-to-end test that begins with the word semantic, and that's just going to run the semantic version validation test. So if you're kind of developing, that might be interesting to you there. If I jump across to the pull requests, what's kind of outstanding, the top one is just to fix a regression about displaying an error message to users. You'll see the second PR here is to enable C groups for non-root instances. So in 3.10, you can start using C groups as a non-root user for Singularity run shell exec if you want, but you weren't able to do it for instances. This will make it work for instances if you have a system which is running C groups v2 and is configured to delegate permissions. And that is also going to open up the ability to have these instance statistics available across the board on systems where that's supported. The one in draft here, this is Vanessa's PR, which was a sort of proof of concept and an exploration of how to build from a Docker file in the Singularity CLI. So this one, it's a great piece of work that Vanessa's done with a lot of code modified here. And really what would be great is to have some other people jump into the discussion around here. So in the roadmap for SingularityCE, we're generally moving more towards closer OCI support. And what that means is that we're really trying to focus on kind of, excuse me, my laptop has just warned me it has low battery even though it's plugged in.
Oh no, save it.
It's plugged in and it's got the charging sign, but it's low battery.
It's tired from the pandemic. It just
so I don't know what's going on here, but hopefully I don't drop. So there's some discussion there about kind of how we ensure a consistent experience as we move towards OCI compatibility and where it fits in to start thinking about Docker files. So I'd encourage people to kind of drop into that one and contribute to the discussion if it's interesting to you. And then this bottom one here, this is about introducing a method of performing builds as a non-root user, but without the kind of previously supported fake root mode, which requires sub-UID and sub-GID mappings and user namespaces. So this one is actually a topic, I don't want to go into it too much now. I think this would be a great topic to bring up in the next call when we have a bit more time. Basically, it's a feature that a lot of people want, but there are different ways of approaching it, and different container runtimes have approached it very differently. We're going down a certain route using a tool called proot because of some observations in our user community. Aptainer is going down a little bit of a different route with a different tool. Charlie Cloud has gone down a slightly different route as well. So I don't want to kind of gloss over this very quickly because I think it needs a decent discussion to explore. So we can come back to that another time. But we're rubbing up against the end of the call now. So I will stop sharing, and have we got any kind of general questions or discussion before we finish at the top of the hour?
You might have talked about this at a previous meeting, but could you briefly mention the change that is planning to happen for the next version, the next sort of major version of Singularity, when I forget what you're removing? Not Oris was removing container D. What was it that you're removing a library that basically is going to have implications for how we might implement something like being able to build from the Docker recipe?
Right. So the idea is that we're going to start using runc or crun as a low-level runtime to run kind of OCI containers natively with full kind of OCI compatibility. And at the point that we can do that, then we've got something in there which is truly OCI compatible for running or executing portions of builds and things. And that's why with that in the forward view, we're a bit hesitant to kind of put new features on which use Singularity's existing runtime engine and have kind of a mismatch with some OCI concepts, right? So for example, if we look at the Docker file, when you're running a container or whatever, and the Docker file has a user line in it, and that doesn't work with Singularity at all at present, there's a potential pathway forward to making that work with this kind of integration that we're going to do. I'll post a link on the meeting notes for this call, linking to the roadmap sections and a document where we talked about that a little bit more again, in case people want to review it. But I think this might come up again like next time when we talk about this kind of rootless builds and things. We'll probably get into the weeds a little more on this topic as well.
Cool, thank you.
Okay, well, we're nearly at the top of the hour, so I think we'll call it for today. Thanks everyone for coming. Thanks, Vanessa, very much for the demo. Is it okay if people have questions, if they ask them in the SingularityCE Slack, or is there another place you'd rather they reach out?
It is okay, however anyone wants to reach me. I am in that Slack, so how that works. If you want to post an issue on GitHub, DM me on Twitter, send a message owl to my apartment, whatever works for you, I will be happy to respond and try to help you out.
Okay, great. Thanks for coming, and we hope we'll see you again next month.
Take care, everyone.
Thanks, Madison.